Alright, so in the next coding exercise, we're going to be building a prime number checker. And a prime number, just to remind you, is a number that is only divisible by 1 and itself. So, for example, 2 is a prime number because it can only be divided by 1 and 2. 3 is also a prime number. Similarly, it can only be split into 3 equal-sized chunks. But 4, however, is not a prime number because while it can be divided by 1 and 4, it can also be divided by 2. So 2 times 2 is 4. Essentially, a prime number is a number that can't be broken to smaller parts other than 1 and itself. And it's this property of prime numbers that makes them really useful to everything from cicadas to Bitcoin and also encryption in the computer world. So if you head over to day 8.2 prime number checker, you'll see the starting code, including the number that we're going to be sending over and checking. And then, of course, the line 11 where we actually call this function and pass over the number. So this part is really important when you are creating your function. The idea is that you're going to be creating a function here that checks whether if the number that's passed in is a prime number or not. And if you take a look at this chart, then you'll see all the prime numbers up to 100 highlighted in yellow. There's a couple of things you need to remember. One is that you'll probably need to use the modulus, which we've seen before. And if you can't remember how to use that, then take a look at this link. Now, the second thing is that make sure that you name your function and parameters the same as what you see here, where it's called. And finally, try to use the same wording as the example output, namely, if it is a prime number, print it's a prime number in this exact wording, and if it's not a prime number, then print it's not a prime number with this exact wording. And finally, if you're still not quite sure how prime numbers work, then be sure to check out the Wikipedia page, and if your first language is not English, then be sure to switch to your native language just to know what it is, because I know it's called different things in different languages. Pause the video, have a good think about this, and see if you can solve this problem. Alright, so let's think about how we might tackle this. The first thing I'm going to do is I'm going to create a new function called prime checker to be in line with this line, because I'm calling a function called prime checker, and then I'm passing in an argument to the parameter called number. So now that we've created our function, the next step is to figure out, well, what do we do in this function? Now, I mentioned that every prime number can only be cleanly divided by itself and 1. So that means that if it's divided by any other number other than these, it will have a remainder. So we know that we can use the modulus to check what the remainder is of a division. So we know that, for example, if we divide 6 by 2, then it equals 3 with no remainder, because 6 is divided into 2 3 times, while 7 divided by 2 equals 1 because there's a remainder of 1, because 2 times 3 is 6, and then 6 plus 1 makes 7. So we can use the modulus to check whether if the number that we're passing in here can be divided by all the numbers all the way down to 2. So, for example, if number was equal to 7, well, then what we would want to do is we would want to do 7 divided by 2 and then see if there is any remainder, and then 7 divided by 3 and see if there was any remainder, and then 7 divided by 4, and then we just go up 2, 3, 4, 5, and 6. And now we've basically divided 7 by all the possible values other than 1 and 7. So if any of these has 0 as the remainder, then it means that it does cleanly divide by one of these numbers, which means that it's actually not a prime number. But if all of these have a remainder, then that means 7 is a prime number, which we already know it is because we can see it on this graph. So how can we go through this process of getting this number divided by numbers starting from 2 all the way going up to the number -1? Well, we could simply just use a for loop, right? So we create a for loop and say for I, which is going to be this number that we're going to divide by, in, and that number is going to be a range of numbers. And the range starts from 2, because we're not going to divide it by 1. We already know that all numbers can be divided by 1. And we're going to put the range all the way up to the number -1. So now, inside this for loop, we can start doing our divisions. So we could take the number and we can use the modulo operator to divide it by I. So it's exactly the same as each of these lines of division. If number divided by I is equal to 0, so if it divides cleanly, well then in this case, it's clearly not a prime, right? Because if that number that we get passed in can be divided by any of the numbers between 2 and number -1 cleanly with no remainder, then that means it's not a prime number. However, if we get to the very end of our for loop and this if statement was never triggered, well then that means this is a prime number. So how can we represent this with our code? Well, we could create a variable called isPrime and set it to true. If this if statement gets triggered, then we switch this isPrime to false. And finally, once we get to the end of the for loop, we can go ahead and check, well, is prime true or is it false? And this expression is basically the same as just typing this, because this is going to be true or false. And if it's true, then we get to step into this block and we're going to print from this example output and say that it is a prime number. But else, or otherwise, then we're going to print the opposite, where we say it's not a prime number. There you have it. This is the simplest way of checking whether if a number is a prime number. And all it does is it checks through all of the numbers between 2 and the number -1. And if it's divisible by any of those numbers, well then it's not a prime. Now, out there in the real world, there's a lot of other ways that you could implement this function. And there's more efficient ways, there's faster ways, and there's lots of algorithms that mathematicians have come up with in the past. Now, for our case, what I'm really interested in is that you understand how inputs work and how you can use the argument that's passed in to the parameter inside your function in order to do something with it. As long as that's clear to you, then that means we can continue in the course and I can rely on the fact that this code or this code will not throw you off and you'll know exactly what's going on when it's being used inside the block of code and when it's being passed over into a block of code. In the next lesson, we're going to be putting all of our knowledge that we learned into practice and we're going to get started building our final project, the Caesar cipher. So for all of that and more, I'll see you there.